Okay, my friend, so you say, Roger, what is this big deal about black holes and what's this new information? Well, today, August 17th, 2022, they're talking about this ring that they have discovered by turning the lights down so they could see the actual energetic reactions on a much finer scale. Okay, I've been studying this shot here where they're showing these fields of interaction based against the glow of the particle. And now I pretty much understand what's happening here. This thing is spinning counterclockwise. And I can almost absolutely certainly tell you that. Because the first impact is up here, creating this bump, pushing this way. So it's spinning, pushing that. Then it hits the well, and I don't know what creates this well, but it is a well here. And when it hits that well, it pushes it this way, creates this bump at the end. You see, this would push, and you can see it's twisting, it's pushing it away. It comes down here, and it's pretty much been pushed, and at this point it's sort of flowing into this well. And that well is driving a field completely out of it somehow, but it's obviously pushing this way. This one is obviously pushing a bump and then a bigger bump and then sort of sliding away, being held in by the field and then whacking into another field, actually driving what looks to be is like a particle, basically. It's another field pushed away, or there's a field here that's interacting backwards and creating an open expanse, something like that. These could all be particles or planets or whatever they are. And when this energy hits against that planet, star, whatever it is, it creates this, maybe galaxy. I don't know. This is supposed to be pretty big. So this is an interaction, a field against field, and a spinning field this way. And then when it gets up into this area, there's nothing for it to bump against, so it sort of just trails off and loses its energy, and it just sort of flows out there. And then it comes back in and bangs into this pusher field. That's how I'm seeing this. It makes perfect sense to me. But it is this is spinning, yes, I agree with that. And this could very well be the zone of impact. I could fully agree with that. And you would see a bigger glow all the way around. And we did see these two glowy spots here, which are obviously something's pushing back at it. So anyway, this is pretty interesting. Okay, well, this is this black hole that they have been studying, and they found that where the emissions are, there's a very, very intense ring, like our ionosphere, basically. Alright, here is the thin film showing the energetic values. The redder, the less energy, the brighter, the more energy. Now, we see these magnetic fields. These are wells of magnetic fields. Now, I'm not sure how to read this yet, but this is what it's all about, is taking your time trying to think about how are these pushing each other away? Are they attracting to each other? Let's take a look at some other shots I have. See, every time you see a depiction of one of these, you see a black hole in the center and a bunch of stuff around it. Now, where do you see this one that the Russians took in space? This blows my mind, and I still can't explain it totally. Alright, this is the one that's really got me sort of in a tizzy. This is the Russians in space with a vacuum chamber and then ionized dust particles. They injected into this vacuum chamber in zero gravity in space, and it formed a black hole. They freaked out, totally freaked out. It says during the experiment we contacted the Earth guys who couldn't believe it either. Everybody was freaking out. One guy locked himself in his office for 3 weeks because he went so crazy. Now, This is a fabulous video, and we're going to watch this and try to understand what's going on with these charged particles. I understand it now to some degree, but I cannot understand looking at this why I'm seeing a black hole here. What if I was looking at it this way or that way? Would I see a wall of whiteness and never see the black hole? It seems every time I see them, you're looking at a black hole surrounded by white. Why? Is the reason because we're looking and we're absorbing that light coming this direction? There's something different about this. Something's very strange here. And you know, if you're a thinker, start thinking. Because I've been thinking about this for years. This was like 2015 or so they did this, and they just went crazy, and everybody else did too, and they just finally dropped it because they have no idea why this happens. I had an idea, but why we always see this black flat hole, that I can't explain. You know, if you think about this, this is almost like it's in its own universe, because the walls that surround this of the vacuum chamber also are coated with electronic particles, and they push everything away from themselves. So all of this is being pushed into the center, and then in the center of it collects a black hole. So is there a black hole in the center of the universe? And all the particles that are spinning in space are spinning around it? Why would they spin, first of all? There's so many questions and so few answers. And it's being avoided, basically. I don't avoid anything, but boy, I can tell you this is confusing as hell. All right, if you've seen the experiments, and anybody's been with me has seen them probably 100 times, this is the light coming out of the Venturi. It creates Higgs fields. These are the actual Higgs fields. These are those particles spinning. Those particles. You see, the light comes in, it goes through the Venturi. When it comes out the other side of the Venturi, we're looking into that light now, seeing this. And this is what it looks like. You see the little black is in the center of the white glowy outside? Those look like black holes to me. All right, I know this is just beyond belief, and I agree with that. However, it is factual and it's evidential, which means you can see it. The light, as we know, goes, the pulse red laser is pulse, pulse, pulse. Now, we accelerated it, as you can see. At the Venturi, it splits. And when it comes back together, just as it's coming back together, it creates these Higgs fields where the black and the white returns together. In between here, it's only white. There's no black whatsoever. Right here is where the Higgs fields start to show up. These are these. And these are also these same particles. These are the same exact pictures, only enhanced to show the energy values. There's a black hole in the center and a little white glow around them on the very tip of every one of these fields. These are Higgs fields. What's that all about? And they're spinning. You see the way they're spinning, 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 spinning? And they make these six-packs. 2, 4, 6. And they make you a 6 and a 6 and a 6. Everywhere you look, there's 6 of them in these six-packs. Now, everything is pushed to shove. You see how there's such well-defined margins between the particles? And these are the particles as they're coming back together and reattaching to the black. That's all I can tell you. That's what I'm seeing. Now, what I'm saying is not outrageous, because we know that these are the smallest particles that exist that CERN and Fermilab can find. This is from Fermilab. These are the particles. We found the exact same particles. There they are right there. Then, not only did we find them, and they conform precisely to what Fermilab and CERN claim to be a muon and an electron neutrino, we then separated them. They're supposed to be glued on together, and I'm going to show you the scientific stuff in a second. They're supposed to be glued together just like that. And light is a batch of them in a little box, 2 particles together. This is a particle. These two together right here are an electron. They call them gluons. It's really an electron. That's what flows through circuitry. It becomes static, lightning, electricity. Two of them together are now semi-stable. They'll bounce off of you and turn into light. You'll see the light bouncing away from it. So this is the particle, and we separate it, which is fission, and here it is right here, separated, and it came back together here. In between is raw whiteness. This is where these black particles start to reattach to the Higgs fields. And this is exactly what CERN says. Muon neutrinos and electron neutrino attach together, crash into Cherenkov radiation, which is heavy water. And you see the muon go on its way to black ball. Never changes, not a bit of change. The white one turns into these showers. Precisely what we showed. And this is the acceleration, and this is the division, and this is the reforming. And right there, looking this way, is where you're seeing these fields with all those dots in the center. So let's revisit it now so you understand. This is this white layer here. And there's nothing there. You can't see anything. It's just, right, well, there it is right here. It's just sizzling out, these little tiny strips of zip. Then all of a sudden these show up right here. Right there. The Higgs fields. And then they just, tons of them come at us. And this is what they look like if you were looking right into these Higgs fields coming at us. You're seeing the black reattached to the white. It looks to me. Down here, they're only white. They haven't come up enough to hit the black yet. It appears. That's all I can say. Some of them have. Some of them hit. But mostly it's only on the tips. All right, take a second here to think about this. We are looking at those little white strips coming at us, which you wouldn't see at all. There's nothing there. It's just a white electron shower. Nothing other than that whiteness. Then all of a sudden, the Higgs fields start to show up, which are these circular patterns. Now, this is the enhanced again. And what can we see? Right at the very tip, the blacks are hooking back together with the whites. It appears to me, this is what the Higgs field is the recombination of the separated particles coming back together. This was a big, huge thing, and then they said, well, now we got to look for the muons. Well, these are the muons. The black part is the muon. And it appears to me right now that these have not found their muons yet. They're still looking for their perfect muon. Now, this one grabbed them. Now, why is this strip here got a little more energy? I don't know. It might be being pushed on from the edge. I don't know. All I can say is you can see them down here, and they form these six-packs. And you got the black and the white, and they're always at the forward-leading tip. Behind it, they appear to still be very energetic, except they haven't found a black particle yet. That's the only way I can see this. Maybe you got a different take on it, but look at it's exquisite pattern of it. I mean, it's just fabulously exquisite when you look at the pattern. Isn't that something? And they just get brighter and brighter and brighter. Well, we get blacker and blacker, actually, as they get to the tip. And now they become, like, back to light again, I guess. What it looks like to me. I'm sort of guessing at a couple of these things, but I can tell you what. When you follow these around in a circle, they just go around and around and around and around and around and end up in the center with a six-pack. Okay, just so this is crystal clear, this is the laser. Pulse, 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 pulse. Normally, that's what the field would be. Not even quite that, stretched. It would be sort of a big round field like this coming through the air, and everybody else, all these little tiny particles, would concuss and glow, as you can see them doing it, because that big wave is coming through. Its electric field is pushing their electric field, and everything has an electric field, so it doesn't matter. Everything becomes a little bit energetic when it's being pushed against. So, what happened here? detected a venturi up ahead, which is sucking these particles through. A venturi creates acceleration, just like it does on a nozzle on a hose. You take a hose and you turn a nozzle and you turn it down tight, it gets tighter and tighter, it gets squirter and squirter. There it is right there. It's very, very, very simple. Well, what did it do? It made that particle itself manifest itself, and it is a particle, and it combines a black and a white side, and they divide here, and as I've shown you very clearly, the two of them separate, and a white shower comes through, the black just stays black, and somehow they get enough of them here to recombine with all these white showers. Now, what actually started here? What was coming through the air? It was a particle like this. Basically like that. It had two glowy spots and two dark spots, and it was coming through the air, and it would flip occasionally, flip and flip and flip, depending upon how much charge was on the one leading forward, because it'll charge up as it hits them. When they hit each other, they charge, and the white ones only charge. The black ones have no interaction whatsoever. They don't absorb, they don't emit, they don't do anything, but they're concussors, and they're the carrier. They always said that they were the carrier. So, here we start exceeding the speed of light. I mean, it's what's happening. And at this point, the particles can't stay together because of the tune of the venturi. Will only allow the white particle through. The white particle can come down here and squish down like a little ball of cotton and come right through there. The black particle is just like this. It comes out as a bang. I say, I can't get through, I can't get through, I can't get through, I can't get through. And it keeps slamming, pushing the white ones through. The white ones say, no problem, I can get through there. I'm just a little squishy white thing, and zip. And that's what happens. Then they come back together here, and this is exactly the spot where we're seeing the Higgs fields. The black ones now come back to the white ones. So the tip of the leading spinning particle, which is the white one here, which is this electron shower, and they are energetic and spinning and vibrating and like hell. And all of a sudden, bang, they hit back into the medium of the world, which has dark matter, and it grabs one onto it. But the dark matter is ahead of it. We're seeing it come ahead with the dark matter ahead of the white matter. That's very unusual. Usually the white matter precedes the dark matter. What a world. Okay, my friends, this is just crazy, because this is from Rod Warren. Did virtually all the pictures I'm showing here. Now, Fabi and Boulay enhanced some of those pictures to show us those black dots and the way the photons emit and how they glow and all that stuff. But primarily it was Rod that did this. Now, his nephew, Dylan Carpenter, sent me some pictures. He got a new phone a little over a year ago, and he went out and took some pictures. He said, what do you think? I said, whoa, wait to see them. They're going to blow your mind. Blew my mind. They still are. I'm still trying to figure out, something about them. I mean, there's just so much that, wait do you see? All right, so he sends me this. Now, everything I say, everything is dipoles, and that's absolute fact, because this is the dipole nature of, I believe this is Venus. There's nothing that has this kind of energy in our neighborhood other than the sun. You see these ones here, there's also dipoles. Black and white, I don't know what these are, they're planets or stars or something. Now, this is the moon. Now you see this blue glow up here? And this orange glow down the bottom? What's that all about? What's going on there? And plus, what is this stuff doing on top of the moon? I have other shots of this that'll knock your socks off in a second. But you saw those field lines that we saw related to the black hole. Well, everything that has energy creates a push-to-shove zone. And that's what these are. Boom, 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 boom. They get lower and lower. The more push to shove is closer, is more energetic. Farther away, they're less energetic. Now, that's why you see those fields dissipate as they get further out. And at some point, they just no longer can get away from it. And because these are particles hitting, coming back, hitting, coming back, hitting, coming back. Finally, they get out there, they say, I'm hitting, I'm coming back, that's it, I'm done. And they come back in, and these are actually particles. We say they're fields, yes, but they're particles pulsating. And at a certain point, the pulsation cannot continue out. On the sun, different story. Watch what happens to the sun. Like I said, sun, totally different story. Normally, you see this is the field coming down, field coming up. This is the moon eclipsing the sun. So we can see the illumination, but we don't get blinded by the light. So what do we have here coming down, coming out? The magnetic fields. Normally they'd come back around, and they'd come around, and they'd go out, and they'd come back around. And at a certain point, they just would stop and not be able to go any further. These, no. These little piggies do not come home. They run off into the world, into the universe, to bang into something later. They are particles. There's ions, there's photons, there's dust particles, there's chunks of who knows what coming off here. I mean, there's a lot of stuff coming off the sun. They call it the solar wind. They know it's out there, but they just ignore it, like it's not even there. And that's why Hubble's such, it's kind of a joke. Hubble is looking through all this stuff, and obviously light is slowing down coming through it. I mean, obviously. They know that, but they just ignore it like it's not even there, and they say, oh yeah, that's 650 million light years away, because light never changes speed, and we know it's that, and the red shifted, everything's going away from us. No, it's not. Everything's slowing down coming to us. It might be going away. I can't say it's not, but they can't say it is. Because the Hubble Space Telescope has no idea what is what. If we're looking through this, it's not like we're looking through this. We look through this and everything's obscured because light is going to slow down. We're looking through this and we can pretty much look right through it out a long distance. We might only be able to see something here 100 miles away. This we can see 10,000 miles away. It's that type of thing. And they're going to look the same because one of them's being interfered with as the light is coming to us. You know, Hubble's really silly, but it takes nice pictures. Now, this is spinning this way, the sun, and which generates a field. They all generate a field. That's why the sun is so hot. The sun itself, you know, is only 10,000 degrees. Out here, it's millions. And that's because this is where it hits the corona field. And it tries to push it back in. It says, no, we're leaving. It says, no, you're staying back in. It's like hell. Pew! Out it goes, and it gets hotter than hell at that scrub zone. Millions of degrees versus 10,000 at the surface. They have no reason for that. They say, oh, it's due to fusion. Explain it to me. Well, and, you know, then it goes on for a week of little squiggles and things all over the place, and they mean nothing. What's happening is everything that's spinning in space is spinning through a soup. And even the Fermi lab calls it the quantum foam, which is out here. It's just all particles. Quantum foam. It's this stuff. We're scrubbing through it. Our zone is our ionosphere. The ionosphere out, like, say this was the Earth. The ionosphere is out around here, and it's 2,700 degrees. We're at 100 degrees or so on the Earth. 2,700, why? And it's minus 85 or something in between. Well, why did it get to 2,700 out here? What possibly could have happened? It's the scrub. The same thing with the sun. Same thing with everything. The harder it spins, the more it scrubs. The bigger it is, the harder it spins. The harder it spins, the more it scrubs. The more it scrubs, the hotter it is. The hotter it is, the more energy comes out. Very simple when you peel it down to its lowest level. The Earth and so forth just doesn't have enough impact to create this emission. You know, we're getting some of it's going out, bouncing back off of our atmosphere and so forth. But primarily, our little piggies come home. These, they're gone. All right, this is our solar system being ripped through the Milky Way. And here's our part of the solar system doing this. And we're just part of the universe and the galaxy and all that stuff. But we're scrubbing through everything in front of us. Let me just show you the galaxy and show you why we're overheating. All right, we're somewhere in the universe here in this galaxy, let's say, and we're being pulled around just as everybody is. You can see it spinning, and these arms are being folded back because they're spinning into whatever's in front of them, pushing them back. creating their push-to-shove zones, which they would call them interference patterns. Really, they're repulsion patterns. I have some material here. I'm going to push you away. All right, you stay your side, I'll stay my side. Yep, 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 yep. And that's how they set up these patterns. Now, we're being rubbed through here. We could be hitting blank space. We could be hitting dense space. We have no idea where we're. No clue whatsoever at the moment. All right, so we don't know where we are. We don't know what we're heading into. And here's the problem, is the sun is scrubbing through everything that's in space just as we are. So if there's a ton of particles that all of a sudden we hit, that's going to make this get hotter and hotter and hotter. That's make us get hotter and hotter, because we have to go through the same stuff, plus we have to go through the stuff that's being ripped off the sun. So some days we get a lot of solar interaction, some days not quite so much. This is understood now, and it's not being looked at in the correct way. And again, our ionosphere out here is 2,700 degrees or so. The Earth is about 100 degrees or so. Why? The sun, the same thing, 10,000 on the surface here where it's bubbled and glowing. And out here it's millions. Why? How did it get to be millions out here? It's because it is scrubbing through those particles. And it's scrubbing so hard that they're taking off and they never come home. Ours go out, they come around, they come back in. They go out, they come back in. So we are really holding on to our particles. The sun is getting them out of there. But it's also absorbing them as it hits them. It has to plow through everything. So obviously it's taking them on and then radiating them back out. How much it takes on, I don't know. Compared to how much it gives out, I don't know. But I would assume that it depends on how much it's taken in, how much it's going to give out, because that's radiation, that's concussion, that's luminosity, it's emission. When I make something concuss, it emits. Okay, I think you saw the glowy image, and that was the image the scientists unveiled in 2019, and it was a landmark. The scientists thought they could sharpen the image and glean new insights by working smarter, not harder. They applied new software techniques to reconstruct the original 2017 data in search of phenomena that the theories and models predicted were lurking behind the surface. The new resulting image depicts the photon ring, comprised of a series of increasingly sharp sub-rings, which the team then stacked to get the full image. Now, here's what they did using some sophisticated software. They came up with this image of what the black hole energy values are and how they interact with whatever this is here. Now, they're calling these sub-rings. I call those magnetic fields. Let me show you some of the stuff we did. It's kind of similar. Okay, so basically we did almost the same thing. We enhanced these pictures to see what the energy values were and so forth. And you can see the dark versus the light. And we're going to get deep into these, what they mean as much as I can tell. Okay, my friends, this is what we have. It's similar to what they're looking at, and it's very strange. Now, as I've been saying to everybody, everything is a dipole, and they spin in space, and they make a dipole. And they make these magnetic field lines around them because they're interacting with all kinds of magnetic fields. All right, I believe this is Jupiter. I'm sorry, I believe this is Venus because it's so hot. And that's what creates high energy white particles. Now, look at this. This is amazing. This was what Dylan did, just with a phone. He got a new phone. This was a little over a year ago. And these are the pictures he's taking. Look at these interactive fields. All right, did you see the stuff they said they used all their sophisticated software to come up with? Look at these things. Anyway, my next one is going to be on the particles in space. Hold on. Alright, there's a video that goes along with this showing how they made this black hole. They freaked out. And they're still freaking out. They have no idea what it is. This was, I think, 2015. It says, during the experiment, we contacted the Earth guys who couldn't believe it either. They couldn't believe this had happened. And for a while, I had a hard time with it myself. But once I could see that the dark matter could be separated from the white matter, these are charged particles, and they are literally surrounding dark matter. And I believe extra dark matter seems to exist or it's so, I mean, it just seems to be everywhere, the dark matter. And it jumps right back in after our light experiments. So it's got to be lingering around out there somewhere. Okay, this one's running along. So the next one is going to be on this kind of stuff. This is a spinning ball of water in space with air bubbles in it, with something that keeps the bubbles separated. Otherwise, they'd make a tube inside there. And they put tea leaves in it and all this stuff. Now, and how it creates a hollow sphere spinning in space. Now, I am going to show you something else that the Russians did that created literally a black hole in space by using charged particles. And nothing more than charged particles are emitted from the sun. Basically, almost 100% are the charged particles. Okay, I'm just going to let this play while I'm talking. And what this is they have plasma. It was first created in this black bucket-like chamber. So the plasma is these charged particles. Now I'm going to let this play, and they're going to inject these charged particles into this vacuum chamber, which is in zero gravity out in outer space. Here goes. Now, so here's what they saw. They saw the particles come in. These are the charges on them. The charges make them glow. You see they ran into streamers? Now, they had expected them to all push away from each other, which they do. And they had expected them to create these lattices. But instead of creating lattices, they created a black hole. You see now they've got all these charged particles. These are dust particles. And they have extra charges on them. The charges glow. So, everything's happening in this black bucket, which is a vacuum chamber. Now they were expecting to see a clean lattice like this and like this. Everybody's pushing each other apart. This is what it settled down to be like. When they saw that, they freaked out. Absolutely freaked out. He said one of the guys in the Max Planck locked himself in his office for several weeks because he freaked out so bad. They still have no idea what it's all about. And what it is, they created the first black hole in space. And anyway, we're going to get it, and there's a lot more to this research. They did, there's all kinds of stuff. And we're going to see how these particles react to one another, how they swirl, and, this is going to be a whole new area of study because this is zero gravity. Now, what the hell is going on? There is so much things to look at out here, and it actually creates almost like DNA. You see that? You see that? I looked at this carefully. It damn sure looks like DNA to me. Anyway, a lot to look at. That's going to be the next video about how particles react in space. What's out in space? I talked about John Glenn before and the fireflies, and all the things that are in space are not what you think they are, my friends. Not by a long shot.